square roots compare real numbers? What is a square root? Well, what's a square? Give me an example of a square. Yeah. Yeah. So what's a square? What's 2 times 2? 4 would be considered a square. Give me another square. Yeah. 36. Give me another square. Yeah. 16. Okay. That's a square because it's 2 times 2. That's a square because it's 6 times 6, 4 times 4. Now the root, what was squared in order to get the 4? 2. What was squared in order to get the 36? What was squared in order to get the 16? The 4. Okay? The root of something. When you think of the root, the origin, the beginning. Okay? Yes? Cubed roots. Not that we'll get into. Like 8s. Right? Would be 2 to the 3 at a monster, right? 2 times 2 times 2. Okay? All right. All positive real numbers have 2 square roots. A positive square root or principal square root, and a negative square root. A square root is written with the radical symbol, your traditional square root sign. Okay. Seen that before, right? Play with it on a calculator from time to time. The number or expression inside the radical symbol is the radicand. So all of these, that's the radicand. Right here, the 4, the 36, the 16. What do they mean it has a positive and a negative? Yeah.
So it's a positive 36 is equal to a positive 6, and negative 36
You got to be careful. These, what they're saying is, you have a 6, but it could also be a what? Because the negative 6 times the negative 6 will still give you the positive, right? Okay? Okay. But sometimes, when they have it on the outside, okay, 0 is has only one square root, and that's 0. There is no such thing as a positive and a negative 0, right? 0 is just 0. Negative real numbers do not have real square roots because the square of every number is either positive or 0. If it's a square, that's what we're saying here. Okay? You could have the negative times the negative, and you'd still end up with the positive radicand. You will see, from time to time, an example like this. If there's a negative in front, just carry that negative over to your answer. What is the square root of 9? What times what gives you 9? 3. Because it has that negative, just put the negative in front. If you see one of these, positive, negative 64. Again, solve for the radicand itself. What is the square root of just a 64? What times what is 64? Mark? 8. And just like here, I carried that over. Carry that one over as well. Yes? Sometimes when they have positive and negative, the symbol positive, it's red plus or minus, refers to both the positive square root and the negative square root. It's making sure that either, it's basically saying, for this one, since they use the plus minus, they are saying that either the positive 8 would work or the negative 8 would work. Some will ask for that. Like we said before, for all of these, for even the 36, I mean, if you want to get technical, they have 2 square roots. They have the positive 6, which is 6 times 6 is 36. It also has the negative 1. Negative 6 times negative 6 would also give you 36. So sometimes they'll just ask for it later. Like, if you put it in front, just carry it over. Okay? That's what it means. All of the examples that we had would be considered perfect squares. Perfect squares are the ones that work out, well, perfectly. So when I think of square root of 9, well, that's easy, that's 3. Square root of 16, that's 4. Square root of 25, that's 5. Square root of 36, that's 6. Square root of 49, that's 7. But they don't all work out that way. They don't all work out perfectly. These aren't the only square roots that are out there in existence. Sometimes you may see something that's like a square root of 48. And square root of 48 comes in between 2 other perfect squares. Yes? 36, 49. 36, right, is 6. 49 is 7. You notice how the 48 comes in between the 36 and the 49. Yes? What would you estimate that to be? Is this closer? Is the square root of 48 going to be closer to 6 or closer to 7? What? Much closer to 7, because the 48 is much closer to the 49. So yeah, maybe you say, I mean, it can't get any closer without actually being, right, I mean, so I mean, you probably go 6.9 for that one. What about a square root of 32? How would you approximate square root of 32? That one would come in between which ones? Do we need this? You read that? Take a minute and copy that down. So let's move back. 32. In between square root of Mark. So that's a 5. That's a 6. Is the 32 closer to 25 or closer to 36? Yes. Yeah, it's only 4 away from 36. It's 7 away from that. If they ask you to pick the nearest whole number that it's closest to, you're going to say 6. If you tried to approximate with a decimal, maybe you'd say what? Sure, 5.7. Okay. So either one. If they ask you for the nearest whole number, just pick whichever one it's closest to. Okay? If they ask you to approximate, do the best you can. Okay? This just shows, if it was 5.5, that would show that it's exactly in the middle of 25 and 36. Right? But it's not. It's a little bit closer to 36, therefore, we'll make it a little bit closer to 6. Okay? Any questions there? Okay. Rational and irrational numbers. Now, most numbers are rational. We'll just go right ahead and say that. Most numbers are rational. You're going to have much more to choose from with rational numbers than irrational. Rational numbers. Anything that can be written in A over B form. You might look at A over B form as a what? Fraction. Anything that can be written in a fraction form. So, for example, as long as B does not equal 0, that's an important part. So, is the number 5 rational? Can I write the number 5 as A over B? 5 over 1, right? How about negative 47? Negative 47 over 1. Okay. How about negative 2.2? How so? This is negative 2 and 2/10. Is that AB form? Not yet. So 22 A over B. Okay? So that would also work. That would also work. When you get to the decimals, most decimals work. What kind of a decimal is this? Terminating or repeating? Terminating. Stops. What about 0.3 repeating? How about just even 3.3 repeating? Is that rational? Yes. How so? Show you a little trick with repeating decimals. If I were to just ignore the bar notation for a second, and I just look at this as 3/10, how would I put 3/10 into fraction form? Listen to it carefully. 3/10. Okay, 3 over 10. However, since it's repeating, there's something special that happens to your denominator. You take 1 away. Now, does that make sense to you? 3/9 is what in simplest form? Right. You know that 1/3 equals what? Right, 0.3 repeating. A over B form, 3 over 9. 1 over 3, A over B form. Yeah. So your decimals, they can repeat. That's okay. They can terminate. That's okay. What they can't do is go on and on and on and on and on without following a particular pattern. Do you know which ones do that a lot? What do you notice? Are these perfect squares, Marlia? No. So when you have those square roots where the radicand is not a perfect square, I mean, that's going to be a majority of your irrational numbers. Okay? So like I said, there's many, many, many more rational than there are irrational. Any question? Let's order these from least to greatest. Okay, least to greatest. Probably the easiest way for us to order them is to get them all looking the same. Put them all in the same form. Can you fix this square root of 49 to maybe look like a regular rational number? Yes. 7. How about this negative square root of 4? Negative 2. Then I've got the 8 and the negative 3. So now, between all of those, which one is the smallest? Which one is the least? Which one is the furthest away from 0 on the negative side? Raven. Followed by which one? Marlia. But I'm not going to write it as negative 2. I'm going to write it as the negative square root of 4, right? In their original form. And then, Mark? And then the 8. So when you order them, make sure you order them in their original form. So a recommendation, do this. Write it out, and then somewhere around your unknown values, put down the known value. It'll be much easier to order it once that time comes. Try one. Are you good? Let's do this. Page 114. Here, 113. Three through 14. And 16 to 28 even. Take a real quick look on page 113. Let's just look at one like number 9. Sometimes you'll get these rather large radicans. But if you really look closely, it's not as bad as it maybe first appears. Focus here on the 25. Square root of that 25 is what? 5. I've got 2 zeros as well. Does it mean 500? No, if I multiply 500 times 500, I'm going to get 4 zeros, right? So what should I use? The 5 and Mark? 50. Because if I go 50 times 50, I get my 25, and I get the 2 zeros. Make sure also that you would go the plus or minus. Remember, you're multiplying the same thing times itself. Okay,